Okay, so guys, thank you very much for having us. And we're going to be talking about humans and AI in financial services. And the first things first, right? I'm the business guy in all of this. And I'm going to go through a little bit of the story. So I'm the human, and Manuel is the AI in all of this, right? And just bear that in mind as we go through this, because it's going to be a little bit of a pattern of how we've set ourselves up, how we think about problems, and actually how you make AI real within the organization. And having this partnership between people who've been in the business for a long time, who know how to dream a little bit, paired with people who are industry-leading AI thought leaders, right, helps you dream a lot, right? And that's what's really important, because our jobs, and you guys are all going to be over very many different fields, is not just about the application of AI because it's cool. It's actually transforming, right? How are we going to do this well? This is an exciting time, and we're investing a lot at JP. And why? Right? We've seen a lot of press articles around the money that we've been putting behind it, the types of talent that we've been bringing in the firm, right? Well known, well publicized. But why? This is one of the reasons. We are everywhere. A lot of people in the rest of the world don't always know about JP Morgan. First of all, because we are predominantly a US bank for our retail business. And over there, we have a huge amount of digital customers, and we bank 61 million households, right? For the international business, the investment bank, which I'm part of, we bank 80%, more than 80% of the Fortune 500 companies, and we operate in over 100 markets, which means we have huge amounts of data, we have a huge amount of information about the way we interact with our clients, the way that we interact within the markets, and ultimately how we, as a company, can interact with other corporates around as well as we do business with them. And why? Right? These are slides you've all seen before. Other people talk about data-driven decision-making. Right? We want to make sure that we are making the decisions based on real motivation. Why are we doing it? When are we doing it? What data do I need? Obviously, all the stuff you know. But let's draw it down to the bottom two, right? Intelligently automating. Incredibly important. We as a bank, and a lot of people don't understand this, have huge operations departments, right? Settling trades, moving money around the globe. And these processes are, age-old, and there's a lot of people doing them. And machines are going to be able to do these better than we were able to do before. Right? So we've got to think about intelligent automation. But the bottom one, right? Commercial impact. A lot of people do a lot of projects like this for science experiments, proof of concepts, things like this. We have to make it real, get it out into the marketplace, right? And make sure that we are having a commercial impact on the bank in an appropriate and ethical way, right? I'm going to always say appropriate and ethical, because we are going to change the face of the workforce, right? What's going to happen to some of the people who don't necessarily have the skills to move forward here? So we as a firm are also investing heavily in the skills of the future, working with local development partners in each of the locations where we have major offices, and thinking about the new university courses, new college courses that we're going to be putting our people through, excuse me, to hopefully enable them to work in this new paradigm, and if not, help them redeploy into other roles in the same locality, right? And again, it's all about these outcomes, right? I'm bringing that whole animation up at once, right? Because again, do we care about how beautiful the technique is to get there? We do. But it has to be done in a practical manner to actually get this out in the field to work, right? Because we have this thing called operations, right? Every system you build today, you don't want a call every hour of the day because a model has failed, right? You don't want a call to have to go and repair something in the middle of the night, or when you've been on your night out at ODSC yesterday night, right? You were networking. Right? So you have to think about balancing requirements against the data and the techniques against the time for delivery. And as I say, the path to production is that bit I was just talking about. And the other thing is create reusable components as you do it. One of the wonderful things of this technology, whilst models need retraining, you can create reusable components across the firm. And quite frankly, and I don't know the size of the organizations you've worked in previously, we're really bad at sharing technology across our firm. Right? Everyone, we've built up in all these silos with incredibly successful businesses, and everyone has built a system to support themselves in that little portion of the business they operate in. And therefore, sharing technology is really difficult. So as we manage this landscape and actually modernize this landscape, we can share more than we did today. So how are we organized and what's the talent? So I'm going to take you back for a second, right? And a little bit of a story. You heard a bit of my biography before. So I am, prior to this 18 years of being in credit markets, I have to say that I'm an accidental banker, right? I'm a failed musician, right? Look it up, Spotify. Loop 82, The New Style Swing. A hard techno album that I had that went very successful in 1996. Yes, I'm that old, right? But I thought I was going to be a music star. It was going to be fantastic, and left university and messing around with all this stuff. But as most of you know, electronic dance music doesn't pay you enough money to necessarily live unless you're right at the top, upper echelons of it. So I took a job in the back office of a bank to earn some money. Right? And then from there, I realized when that light bulb moment went on to say, actually, you're not that good at music. Damn, right? Everyone has these awakening moments. I better get serious about this banking. So I started getting serious about banking, moved from the back office into the front office very quickly. And one of the things that separated me from a lot of the traditional people in the organization already was my ability to use technology. Back then, just being able to do a bit of VBA set me apart from everyone, right? Moving risk reports around, manipulating numbers, that made us a bit quicker, faster, and better than our competitors during that period. Right? And throughout my whole career, it's been about using technology intelligently to set us apart from our competitors. Right? And that's one of the reasons why we were able to take a lot of businesses that we've been involved in from league tables of 7, 8, 9, all the way to be number 1 or number 2 in every business line that we are in. Right? That's, bar none, is how we operate. We go really hard at it, but technology plays a really key role. So as we move forward to this brave new world where I joined the whole machine learning and AI side officially, that all came about because I complained about how we were set up inside the firm around these topics. We had amazing talent, but that talent didn't understand our business. And making technology contextual is the only way you can have success with it. So we truly believe in this left-hand diagram, which is having business partners, business-aligned data scientists, the people embedded right next to people doing business so they can learn about the process as well. Having teams of specialists who are technique experts in the center. Having research and AI research, which you're going to hear a little bit more about from Manuela and the types of problems they work on there as well, because there are some programs that are too risky to take on in the business. They need deep thought. They need partnership with academia. They need partnership with other corporates. And so therefore, you need an AI research arm, which is incredibly important. And then you need a platform to work on. But don't forget that bottom bit, strong data use controls. Can you do with the data what you want to do with the data, right? We're not paying enough attention by it. There's a great sentence, again, I'm going to steal one of Manuela's lines from last night that we talked about. But we do need to lose control of our data a little bit, right? Lose control to regain control of the outputs. Right? Really important. Think about that, and we'll go through. So at JP Morgan, how are we set up? So I said, right, we have the business partners, but we have a whole team of embedded data analytics folks sitting next to the business, getting deep down and dirty in the process. Why do we make a payment the way we do? Why do we settle a bond in the way that we do it? Why do we talk to a client with that specific set of information? And we'll work with the business and those embedded folks, to come up with the initial set of solutions using the tools and libraries that are around. Now, we understand that people, if they're going to get very close to a business, can't always stay fresh with all the techniques all the time, but also may not always possess the knowledge about the techniques. So we have a machine learning center of excellence that spans across every business that we have, that is a horizontal, that provides people with specialisms all the way from NLP to reinforcement learning to active learning to whichever other topic you want to talk, speech, etc. Right? And this is where the technique how people live. They don't face a business directly. Their clients are the embedded folks. Right? And really the way I talk about it is, and to talk about this group is the applied research. They will take white papers that are already out there or open source code and bring that into the firm to use. Right? And turn them into components that the rest of everyone else can use. Then the next layer is Manuela's layer, the AI research, where there is a continuum of problems that are really hard to solve, that can't be done by these folk, or require a longer-term thinking or things like that, will be communicated and passed to the AI research group. Now, on top of that, the AI research group is in the business themselves, imagining about how to change things. So there's a number of projects they're doing which are of their own back, not just fed through the business. Right? This is where the dream big comes in. Dream a lot about what could change. And then we have engineering services and data engineering services, which is core and critical to everything that we do. Right? And again, don't underestimate the amount of stuff you need to do with your data pipelines and things like that, because we were not born digital as a bank. We have wonderful databases that I think we have one database down in Tampa in the US that does our payments. The two database administrators, between the two of them, have a work experience of 92 years operating this thing. Right? Imagine that. What's in their heads? How old is this system? Is it going to be, can we really extract the data from that? It's really tough. And so we need a lot of work around the data engineering to make sure that we get the data to the right people at the right time. So where are we doing? What are we working on? So I'm going to go through a couple of these things that we've been public about in the papers already, but it's important because this is now making it real. We are the first bank to actually have machine learning and AI-powered algorithms in the business working that the regulators have signed off on. And again, so just take one step back. We are a regulated firm being a financial services institution. So whilst we can never be at the full cutting edge of anything we do because the regulators will always have an opinion, and we're taking them on the journey with us, we're still the first, and we can still push the boundaries. Right? So we have this thing called RoboTrader. This is a perfect example of humans and AI, because we're building a full framework that can quote and quote prices on and the hedging activity of equity derivative product. Right? How do we make sure the machine knows what to do? Well, it's also working with the traders, working with those people very closely to design these systems. What's really beautiful about this, though, is whilst this takes away the day-to-day, the machine knows when to put its hand up and say, I don't know. This is something I haven't encountered before. This is an area that I will need some help to do. It's an unknown occurrence, and it's important, that interaction between humans and AI. It's how we develop everything, and that's, you can see with the setup that we have. And this machine is actually amazing at doing that. Right? And again, remember that as you design your systems, always have, through the feedback mechanism or something, an ability to put your hand up and say, I don't know. The other one, R3, reconciliations. This goes back to the operations business that I was talking about before, where we have a lot of people reconciling one set of numbers to another set of numbers for another system. Machinery should do that, right? There shouldn't be people doing those kind of jobs any longer. And it does it far, far better. It learns over time, and also it does it at a faster pace. And what does that mean? It then improves the client experience of working with us. We can get things through our pipes quicker than everyone else because we have machinery helping along the way, right? And again, machine learning through its everything with the proper feedback loops gets continuous improvement. And so we'll go through a couple of other very quick examples. Oh, there we go. Went one too far. We've already put it out there that we are working on client reference data remediation. We have multiple systems, we have data all over the place, and Manuel and I were talking about this at breakfast, we still had people, and we still have people, cleaning up data. Lots of people going through cleaning up data. Again, machinery, computers. Computers are really good at this. So therefore, let's put this into action. Programs underway on that. LIBOR transition. Now this is great and awful. LIBOR transition had to happen because of nefarious activity during the financial crisis around the way in which people were talking about LIBOR and actually manipulating those LIBOR markets. So we needed new reference prices within the market space. So we had to go through this thing where we're taking LIBOR out with all the new reference prices or reference markets. But there's a huge amount of documentation in all our transactions that reference this thing. So we have a wonderful project. We're now actually digitizing all our documentation that's been forever in paper form, analyzing it, using that to go through this LIBOR transition, understand our risks, but most importantly, we're digitizing information, right? This is the other thing. For years, in all of your organizations, People have been writing their notes on Post-it notes. They've been putting them into their little private Excel spreadsheets, and they've been relying upon memory as being part of their IP. We're over that now. We've got to get to a world where information is digitized so it can be used in the appropriate manner. Programs like this help, but also as we move technology forward and make it easier for people to interact with the machinery, it will also happen as well. Market surveillancing, just great big data problem and anomaly detection. I think that's something that's been well telegraphed. But we were very public about a program called Activism. Right? A great example of actually something exceptionally simple. Right? It's just pure getting your data into order rather than anything too fancy on the machine learning or AI side today. But actually getting organized about your information and presenting that in good dashboards back to the business immediately drove value. And we were able to advise our clients when they were about to be attacked by an activist shareholder, quicker than our competitors were able to. Right? Understanding who holds shareholdings in who, how people have reacted beforehand, and it was just a pure data aggregation exercise. But the power of getting that data layer right, immediate value. Roles-based access controls, and again, the sales and trading analytics recommender, all part of the same thing. Get your data in order, analyze it, and you let the machinery tell you what are the patterns, what people are about to do. Recommender systems are very easy, but the roles-based access control, you have multiple people in your organizations who are paid to work out what people should have access to and not. Again, we can spot patterns and come up with gold standards on that. Right? And prospecting, again, very similar to the activism through data just aggregation, understanding which companies we should be talking to about which deals. But I'm going to hand over to Manuela now because the handover point is this thing called the email virtual assistant. Right? The whole thing about this is we get tons of emails coming into the firm. 60 million, I think, is the number that come into our back offices, into these shared email boxes, that are all about where is my payment? Where is my trade? Right? So a person today takes that email from a shared mailbox, sends it to somebody else who is responsible for that particular problem once they've read it. That person then looks at the problem, goes to the system, looks at what the problem is, and then drafts an answer. Then sends that draft answer to somebody else to check it. Right? And then once that person has checked it, then they send it back to the client. Great process, wouldn't you agree? It's really good client service. No. Right? So now the machinery is reading the email, classifying the email, going to and extracting all the entities from it and getting the intent from it, going to the source systems, working out what the potential solution is or the answer to the client. At the moment, what it does is then do that draft for somebody to check. Right? We then look at, so we still have a human in the loop today, and it's appropriate to do so. And as we get our confidence levels up to the point of where the humans are making less amendments to those emails, then we get to a point where we will all fully automate this. And client inquiries are dealt with end-to-end very, very quickly. Good client service, good use of technology. But what makes this better? Learning from feedback. And that's what's incredibly important. So we're going to invite Manuela onto the stage now, and she's going to take you through some of these projects that she's dreaming about. But tie it back to, number one, the partnership that we have, because it's bringing real business knowledge into what we're doing, and they're applicable to a lot of what we do in the bank. But also techniques and things like that that really fit well with Manuela's and her team's skill set, because this is stuff that still requires a huge amount of research. So please welcome Manuela onto the stage.
Okay. Thanks a lot. Thank you very much. Thank you all for coming. As I listened to Samik talking, and as I listened to I was reading the topics that you are facing this afternoon or later today, I just want to spend 1 second telling you what is AI. In case you all know, you listen again. In case you don't know, you'll find out. So the important thing about these, and this is why humans and AI and all of these are so important, is the following. So AI, believe it or not, is a very young science. We're not talking about Descartes, we are not talking about Aristotle, let alone talk about anything. It's very young. It's like 50 years, basically, in which people have been believing that machines, computers, code, AI, the other day I was at this conversation and someone was mentioning AI as if AI is a cat or a dog. And I'm like saying, no, you know what, it's just code, if then else statements, objects, I mean, it's just code. And people are believing that machines can actually do a lot of the things that people do. So there has been this beautiful kind of recent history of, instead of just thinking about machines, to really do all the number crunching that was planned for machines to do, multiplying, square rooting. How many of you can still do a square root by hand? I can. Oh, there we go, some people. But not many of us can do it because we just delegated to machines to do it. One day probably we'll delegate machines to doing many other things. How many of us drive with a map in our car? A real map? Not anyone, right? So, I mean, we have delegated this navigation thing to machines. So what I'm saying is like this. It's a young science. It's a science that's very ambitious, trying to have machines do everything that humans do. I mean, that's crazy. All the way to understanding that because it's young and because it's so ambitious, it's built of many little parts. You know, we do like this natural language processing, and then we do vision, and then we do search, and then we do knowledge representation, and then we do all sorts of now techniques for deep learning, and reasoning, and uncertainty, and constraints, and you name it. So it's a science of little pieces. Machine learning is one of the pieces that is very, very important, but it's also just one piece. So AI, in the examples that actually Samik is telling you, there is this ambition or this engineering or this goal of putting these pieces together. And ideally, the machine learning that does the classification becomes the system that searches for possible choices on actions to take, that eventually makes the recommendations about the email, and so forth. So in some sense, I was, when I was walking by, there are many things here under the ML kind of like label, machine learning for this, machine learning for that, machine learning for this. But AI is a little bit about automating the putting these pieces all together. So that somehow, while at JP Morgan, we develop these individual components, we also aim at trying to create this integration, in particular these email assistants. So what I've told you is like this. It's a young science. It's an ambitious science. It's inevitably, because of its goal of trying to do what humans do, a science of pieces. And ideally, slowly, we integrate them. The last thing I need to tell you is that something that you might know, but maybe the whole world does not know, is that AI is very brittle and does not know much. I mean, we don't know many things about how to do AI. So when people think that AI, machine learning, is solving all the problems, you know, we have to step back these expectations and understand that AI, I mean, we barely even like, so there was this mention to robot soccer. I mean, these robots that eventually move, like, what is that? Do they know what the ball is? No, for them it's some kind of orange dot on the field. That's basically, so the level of understanding is limited of these systems, though they can perform eventually interesting functions. So young pieces putting together and limitations. So this, when we get to this limitations part, and when we understand that we are still building these AI systems, is where humans play a tremendous role here also, because inevitably, these AI is also not only to put robots up in Mars, or not only to do robots that solve our health problems, they are supposed to be part of our daily life. And therefore, there are humans in daily life, and hopefully these humans can indeed, how do you say, compensate for the limitations of AI, and AI can be like helping humans with their limitations. So there is this inevitable science of trying to put humans and AI together. So along that, I'm going to mention a few projects very briefly, but that try to illustrate these aspects of humans and AI. So in this very, very compelling email virtual assistant, the thing is that we basically train a system with a lot of emails classified by humans. This is about the transaction. This is about an account balance. This is about your trade. And we have now, we all know, machinery that is capable of learning this mapping between that kind of features of the email and the classified label that humans gave. However, again, it doesn't do it always right. So there is this thing about part of AI that we should talk more about. There should be more, I really think there should be more papers up there in the list of papers on how do we incorporate feedback from humans into AI systems. And this idea that this is an online learning kind of idea, it's important. And it's not just plain reinforcement learning algorithms. Learning, online learning, we need to get that. So when we started working with the business on this email virtual assistant, so I had an opportunity to actually meet with the person who was in charge of this development, and I asked him, so what happens when people, the operators that get the email classified, this is an account balance, what if it's wrong? And there was this thing about saying, well, that's wrong. And then we started thinking about how do we embed, how do we build upon that feedback? And let me just tell you, and I'll show you these, this is what we call this Serf, selective use of user feedback, because what happens is the following. Hey, these humans, are they trustable? What are these humans telling me that this is not about an account balance? So there is this thing about humans, right? So humans are a mystery to all of us, you know, because they can be helping, and they can be randomizing, and they can be whatever. So there was this thing about what should we do with that feedback? This was not the beautiful training data that someone carefully classified, and now this is deployed. They are using it. And some random user is going to say, no, this is not about the account balancing. So we developed this system, we tried to understand, and we are still in this business of trying to understand how to use these kind of loop of deploying, retraining, and getting this curated feedback. So we developed this Serf, which becomes this selective use of users' feedback. And I don't have here the technical details, but basically, actually, I was expecting another slide, a second slide, but basically, I don't have it. I only have this slide. But basically, I want to explain that what we do is a very interesting kind of labeling the user in levels of trust. So we assign a trust score to the different users. We are talking about hundreds. We are talking about a very wide class of users. And so by actually understanding the feedback they give you, like whether it's right or wrong, we build a trust, and then we weigh that feedback before we give it back to the machine to be trained. Otherwise, we may be damaging the machine through the feedback. Ideally, we don't have it yet, but what we are doing in terms of research is ideally to actually build a bank of, a bank like a portfolio of classifiers. The classifiers only with this kind of well-designed training. Another classifier that used lots of feedback from these people we trusted. And another classifier which merged everything together. And another classifier. Think about the power of having now these differently trained machines, and you get a new email, and now they all vote. I think this is an account balance. I think this is account balance. I think this is a transaction. I think this is a question of where my trade is. And now you actually have different machines trying to eventually, given what they were trained with, to try to guess and make the prediction of the label that is missing. Do you understand? So there is this thing, the only reason, in fact, we didn't have this slide yesterday, and I asked Jackie, who is helping us with the slides and with everything, and I told her, get John, who is in New York, send one slide about feedback. Because after all, when we'll talk about these systems, there is a need for all of us, wherever you are, to understand that the machine learning algorithm you'll have may not be right if you deploy it. And it's perfectly fine. The only problem is that it needs to get better. And I do mention to you this because there is a lot of belief as we move that AI and machine learning is this one-shot deal. We do it, we are done. We'll never be done. We'll never be done. More data comes, things change, things are dynamic, the machine didn't get enough data. So this thing about thinking that when we do AI or machine learning, it's like buying a refrigerator. When it works, we are done. It's not like this. Or buying like whatever technology, all the technology developed by humans works. It's a problem. I mean, in the sense that we have been in the business of inventing technology that works. Toasters, refrigerators, cars, everything works the day we buy it. Imagine one day if you buy a refrigerator, open it, and it doesn't freeze. And you say, come on. What if you have to teach how to freeze? Freeze means put the temperature at this level. That's what I mean by freeze. And then the next day it was everything is a block. And you say, well, I didn't mean that much. And you are trying now to adjust it. We don't have this experience with anything except humans, which we very kindly and generously teach. But you have to move your way of thinking to these AI and machine learning being also targets of this interaction with humans to eventually converge and humbly become better over time. Okay, so when a machine learning algorithm doesn't do something right, or an AI system doesn't make the right recommendation, there is nothing wrong. There's nothing wrong. The only wrong thing is that if they stubbornly keep saying the same thing over and over for eternity, that's what's wrong. Okay, so this beautiful concept, which is never, we focus on explainability, we focus on values, we focus on ethics, and we forget to focus on this online learning, on the feedback problem. So this is my chance. I see you all here. You guys are all like into this data thing. You have this passion, hopefully, for computing and data. Think about these error coming down over time. There is no one-shot anything. Okay. A little bit longer than what I expected, I'm sorry. But I'll explain the next one, which is also interesting. So we all know, so the first thing I told you was feedback, young science, and so forth. Now, we all know that recently, and I've been teaching AI for 35 years, so this for me is recently, we actually made this tremendous step in the science of labeling by using these deep neural nets that are able to learn highly nonlinear functions because of all these layers, highly complex functions, and we magically, literally, can now classify thousands and thousands of objects with very high accuracy. Yes, we can have adversarial problems, we can have GANs, but we still can classify cats and dogs beautifully, tables, chairs, everything beautifully. So this power also, not only of the classification of the neural nets, but the image aspect. The fact that an image, which happens to be a matrix of pixels, of numbers, is a representation that enables you to, with CNNs or with all these convolutions, to be able to classify. So this is where we are. I was brought to these kind of like environments, the trading floor, where basically people, if you have never been to a trader's floor, it's like in the movies. People sit in front of all these screens full of functions. And as I was walking through this place, I mean, the AI professor that is now at the bank, and the people that are over the bank were not AI professors, and vice versa. And so they are explaining to me all these things about derivatives, bonds, assets, blah, blah, and I could only see these pictures on these screens. And I wondered, I mean, it's a very interesting kind of like combination, I wondered, if our AI machines, our neural nets can classify objects, tables, shares, and so forth, can we actually also classify this image? What about if we actually use the image, not the actual numbers, but the picture? And basically, we built this system called Mondrian, which is able to label with up to 95% accuracy. Basically, you take this image, we represent this as a candle representation. It doesn't matter, this black and white kind of representation of stocks going up and down. And we create images of these particular kind of like screens. And then we train a neural net, not for cats and dogs, but for buy and no buy decisions. And this Mondrian system was able to, up to 95% accuracy, reproduce the same decisions. Whether they were right or wrong, I don't know. The fact is that whoever said this was to buy and whoever said this was to no buy, we held a big slice of the labeled decisions, and the neural net was able to reproduce them all with 90%, then 95% accuracy. We are now, as we speak in these big problems, analyzing a big science of actually using images to even make predictions of prices, believe it or not. So that it's not just a decision, but the actual price. Because the price, you know what? The price will represent a different image. So we would love to predict whether that's the next image after this one. Another story for some other time. But look, the combination of eventually knowing what can be done in AI and the particular domain, and you now do this in a novel way. The last thing I'm going to tell you very briefly about another problem that's very interesting. So I told you about Serf, the feedback. I told you about these Mondrian, the use of images. And I'm going to tell you about these payment systems. Again, when I get to the firm, what like Samik was saying, one of the major activities of the bank is these payments globally. But you know, there was this word that was used while describing it to me that made me like, aha, which is, what is a payment? Is a movement of money from one location to another. So I had been in the robot business all my life, and the whole thing about robots is how do we move them from here down the corridor without hitting anybody? So basically I thought, my God, this is about motion. This is ways. This is like just knowing the actual possible paths and trying to route things through these paths. So we basically looked at the data we had, which had never been plotted as a graph, and we were able to do reasoning about routes, about volume, about optimizing paths, because we now looked at the problem as this bank is connected to that bank, this bank is connected to that bank. It's not a fully connected graph, actually. And we had data to know which intermediaries, which motions, which paths had this money gone through, billions of transactions, tons of data that actually revealed where the traffic was. It's almost as getting like tons of data of the traffic of New York and knowing which routes do people use. Do you understand? So the beautiful thing here again is to try to use this to build the New York maps of banks, or create the Uber ability to route on those the money. Do you understand? So again, you have to know your AI, know your business, and make that kind of novel way of thinking about problems such that you can bring the AI power, the AI reasoning, the machine learning power to the businesses and try to improve how things are done. The final thing that I'll tell you, so this is the representation as graph networks of the payments, but the final thing I'll tell you is something very dear to my heart, which is this issue that we all face, or maybe we all don't face, of having to write reports, slides. So we have like these, at least in the bank also, these demand or this need to what is it called? To make decks of slides. You know, this word decks is news to me too. I never heard saying decks of slides, but now it's decks of slides. But anyway, so what I'm telling you is like this. There is this thing about doing reports also. So again, when I look at these reports, hundreds of pages of reports, what happens is that these reports write in English things that were in files as numerical files or speech files or all sorts of things. So we have automated the actual translation of these data to these reports. So we were able to create all sorts of going from Excel files to sub-representation, and then we can automatically identify drivers and outlets for and offsites for these particular kind of information. We can allow people to customize. We can actually generate this natural language for insights. Very simple natural language. It's not really Shakespeare. It's basically saying things went up, things went down. This is like an increase, this is a decrease, this is the totals. All language that comes directly from these numbers but it's generated automatically. And if you have some parameters and something is above some threshold, it will find out automatically and say in language that. We can actually also do something very interesting. Because the machine actually generates now the report, it includes hyperlinks. So you can click on the hyperlink and tell you, not like our papers to tell the publication where it comes from, but what does this term mean? How was this number 2.3 something computed? And this explanation thing that you have also outside as one of the topics can indeed be, how do you say, triggered by this demand. Click here, it will explain how this came out. Why are you saying 4.4% up? I will explain. And in fact, as we do the research now, as I was explaining about the image that is going on, the research here, you know what, is about different levels of explanation. You click once, you get one explanation. You click twice, you get further explanation. You click 3 times, and this thing goes even further in explaining. And we don't go all the way up to the Big Bang. This finishes at level 3, but it could go up and up and down and down. But it's also interesting because explanation is not a universal term. It's a relative term. Maybe some people need more than others. And so to finalize, this is what I was telling you. Young science, integration of parts, feedback from humans, all the ability to actually connect images to decision-making, be it trading, be it others. And definitely this concept of both understanding the data in novel ways and actually also to be able to automate a lot of the processes that people make by hand by making this translation. This is not French to English, but it's machine language, numbers, files, databases, to natural language, which is what humans understand. Thank you very much.